All right, today we're going to be talking about congruence transformations. A transformation is when you map something from one figure onto another. Okay. The original is called the pre-image. Okay. The new one's called the image. Now, you may think that seems kind of weird, but think about it this way. If you take a picture of something, okay, and you look at it on the computer screen, what's the thing on the computer screen called? It's called an image. The image on the monitor, right? So the image is the new one. The pre-image is the original one. Okay? And there's three basic kinds of congruence transformations. They're also called isometries. Iso means same. Okay? Like an isosceles triangle has two sides that are the same. Metry as in measure. So the metrics, like the metric system measure. So things that are the same measure. There's three major ones we're going to deal with here. First one's called reflections. Reflections. Put this in your own words. Talk to your teammates. You have 5 seconds. Go.
Flips.
2, 1. Time. Ma'am, in your own words. Go.
So reflection is like the flip.
Flip. Great. Or someone else. Besides flip. Sir.
Reflection.
Reflection in your own words.
I honestly didn't read this. So.
Okay. Yes, ma'am.
Look in the mirror.
Look in the mirror. Great. Flip. Mirror image. Great. Reflections. Okay. Symmetrical. Yes. Rotations. Rotations. Put rotation in your own words. 5. Go. 3, 2, 1. Time. Sir.
Spinning it.
Spin it. Great. Pretty simple, right? Turn it. Last one, translation. Translation. Put in your own words. Go.
Slide.
Go ahead and say it. Yeah. Slide it. Just slide it over. Shift it over. Okay, scoot it over. Whatever you want to call it. That's a translation. These are all things you could do to rocks. Okay? Now, there's other ones. There are other transformations that are not congruent, such as dilations. Dilations where you make something bigger or smaller. How many of you gone to the doctor and they dilate your eyes? Anybody? When they dilate your eyes, why do they do it? What do they do? They put little drops in to make your pupils bigger, so they can actually look inside your pupil. It lets more light in. Then you have to wear sunglasses afterwards, right? Or, in the case of Mr. Kuhne, my first year in college, I came back, went to the doctor. It was a day kind of like today's, lots of snow outside, but very, very sunny. Brought my mom's van and went to the doctor. They dilated my eyes. I never had this happen before. So I come outside. They didn't give me the sunglasses. It was sunny and snowy. The light bouncing off the snow into my eyes. Tears are running down my face but I've got to go pick up my mom. Because she's at school. She's a teacher. I got to go pick her up. So I'm digging in my mom's van like, oh my gosh, my eyes hurt so much. Oh. I put on my mom's white-rimmed sunglasses. That still wasn't enough. Dig around, I find my grandpa's sunglasses. Put those on over the top. I'm driving down the road, tears slowly drying, pull up. My mom's like, what are you doing? Like, they dilated my eyes. Oh, you shouldn't be driving. Thanks. So yeah, dilate it, just make it bigger or make it smaller. Okay? Make it bigger or smaller. Then there's also stretching. Now, dilate is when you make it bigger in all directions. Stretching is just make it bigger in one direction. But which of these could you do to rocks? Can you reflect a rock? Yes or no? 1, 2, 3.
Rock?
A rock.
Like gravel, like a rock.
A big rock. Can you reflect a rock? Yes, you can flip it over, right? Can you rotate a rock? 1, 2, 3.
Yes.
Can you translate a rock?
Yes.
Just slide it, right? Can you dilate a rock? Not without massive amounts of heat to turn it into magma and something so that you don't burn your hands off when you touch it. Can you stretch a rock? Same thing, right? These are called congruence transformations, where the new one is the exact same thing as the old one. Okay? The image is the same as the pre-image. These are congruence transformations, also known as isometries. Iso meaning same, metry measure, same measure. Now, if you open your book to page 298, we're going to look at one of the problems that you'll have to do. This is like number 5 and number 6 on your homework. On these, they're going to want you to tell what kind of transformation is it, and then they're going to want you to verify that it is an isometry. How can we tell if it's an isometry? Well, we have to show that they are congruent. Everything's congruent. How can we show everything's congruent? Well, if it's on a coordinate plane, we show all the sides are the same. So if we look up here, we've got triangle ABC right here, and triangle XZY down here. Everybody look at this. Think to yourself for a second, which one of this is this going to be? Reflection, rotation, or translation? Just think. Just think. Say it out loud. 3, 2, 1, go.
Reflection.
That's reflection. Great. For it to be reflection, all the sides have to be the same length. So let's find out how big AB is. Well, we're going to have to use the distance formula. We can do that, right? We know the distance formula. x1 minus x2 squared, y1 minus y2 squared, add them, square root, then simplify. So let me find the coordinates for A. That's going to be 2, 8. And B is going to be 6, 7. So for AB, x1 minus x2, 2 minus 6 squared, y1 minus y2, 8 minus 7 squared. All right, what's 2 minus 6? Everybody, 1, 2, 3. -4. What's -4 squared, everybody? 1, 2, 3. It's always positive, 16. -4 times -4 makes it positive. 8 minus 7, everybody. Positive 1. Squared is 1. So that's going to give me the square root of 17. So that's the square root of 17. What side matches up with AB down there? XZ. So to here we have the coordinates for XZ are -2, positive 2, -8, and 6, -7. So we're going to do the same thing. XZ. So we're going to take 2 minus 6 squared, and then -8 minus -7 squared. All right, what's 2 minus 6, everybody? -4. Hey, that sounds similar. What's -4 squared? 16 plus -8 minus -7. -8, so it's going to be -1 squared. What's -1 squared? 1. So that's going to get us square root of 17. Are those the same? All right. Are we done, though? Just finding one pair of sides? No, we have to do all of them, actually. And if you're looking on page 298, it's the exact same problem. They did all three pairs of sides. Can you do that, though? Can you handle that? The distance formula 6 times? Okay. It's a lot of work. Okay. We'll put on our big kid pants and we can do it, all right? Now, Take a look at problem number 5 on the homework right there. Just on the next page. That's the first one where you have to do that, okay? Now, do you need to find the distance of yz using the distance formula? If it's going like this, do you have to use the distance formula? No, we can just count that, can't we? But can we count when it's going up at a diagonal like this? No, there we got to use the distance formula. Also, look at number 5. What's the scale for every box there? It's 2, isn't it? It's 2. So what would be the coordinates for z? Everybody take a look at that. Think to yourself, what would be the coordinates for z? 1, 2, 3. It's going to be -1, -3 for z. Okay? Coordinates are 2 for each box. That's halfway in between. So you can find the coordinates there on your own. Any questions over those? All right. Your homework for tonight from this section is just page 299, numbers 1 through 6. We're going to get started that in just a few moments. You also have page 358, numbers 11 through 16, and 27 through 30. That was the assignment from Friday. I'm adding that on to today's. It's not super long. Yes, you have all told 16 problems of homework. That's still shorter than some of the other assignments I've given you, right? Plus, some of you started page 358 on Friday, so on Thursday.